To solve a radical equation like this, the first thing you want to think about is to square both sides of the equation. If that's what you are thinking, then you're right. We are going to square both sides. This simply means that on the left, we're going to have the square root of 3x plus 4 minus the square root of x plus 2. While on the right, it is going to be the square of the square root of x minus 3. Then the expression on the left is expanded. If we expand using the binomial expansion for a perfect square like this, we are going to have the first term as the square of the square root of 3x plus 4. The middle term is going to be minus 2 times the square root of 3x plus 4 times the square root of x plus 2, while the last term is going to be plus the square of the square root of x plus 2. On the right hand side, it's much easier as the square cancels out the square root, giving x minus 3. Then simplifying further, we have for the square of the square root of 3x plus 4, we have 3x plus 4. Then the middle term becomes minus 2 times a bigger square root now, because both expressions in the square root can be combined. That's 3x plus 4 times x plus 2. And the final term on the left hand side is going to be x plus 2. That's equal to x minus 3. Then we short things up by bringing the like terms together, while the radical is sent to the right hand side. So we have all the terms in x together, 3x plus x on the left, then minus x when we subtract x on the right hand side from both sides. Then the numeric terms plus 4 plus 2, and adding 3 gives plus 3. While on the right hand side, it is 2 times the square root of 3x plus 4 times x plus 2. So that on the left, we've got 3x plus 9. While on the right, it is 2 times the square root of 3x plus 4 times x plus 2. Once again, we square both sides so that the radical symbol is eradicated. When we do, it is 3x plus 9 all squared. That's equal to the square of 2 times the expression in the square root. Expanding the expression on the left gives 9x squared plus 54x plus 81. While on the right, it is going to be 4 for the square of 2. While for the expression in the square root, it remains 3x plus 4 and times x plus 2, as the square root cancel the square. Then the expression on the right is expanded so that on the left we still have 9x squared plus 54x plus 81, while on the right it is 4 times 3x squared plus 10x plus 8. Still, we will distribute 4 into the brackets. This simply means that we've got 9x squared plus 54x plus 81 still on the left hand side, while on the right hand side it is 12x squared plus 40x plus 32 when we actually distribute 4. Then we bring the like terms together. To do this, we will be subtracting 9x squared, 54x and 81 from both sides, so that on the left hand side we are only left with 0. And subtracting 9x squared gives 3x squared on the right. Subtracting 54x means we have negative 14x, and subtracting 81 means we have negative 49. So we now have on our ends a quadratic equation, which is 3x squared minus 14x minus 49 equals to 0, where we can factor or use the quadratic formula in order to get the values of x. If we are to use the quadratic formula, a is 3, the coefficient of x squared, b is negative 14, the coefficient of x, and c is negative 49, which is a constant term. And the quadratic formula is x equals to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Thus, x is minus negative 14 plus or minus the square root of negative 14 squared minus 4 times 3 times negative 49. Everything over 2 times 3. So this is 14 plus or minus the square root of 196 plus the product of 4, 3 and 49, which is 588. All this over 6, which is 2 times 3. This means that x is 14 plus or minus the square root of 784 over 6, where the square root of 784 is 28. So we've got 14 plus or minus 28 over 6. Then we split this up to give us x is equal to 14 minus 28 over 6, or 14 plus 28 over 6. That simply means that x could be negative 14 over 6. That's about negative 7 over 3. Or x is going to be 42 over 6, which is 7. Now you might think that we've gotten the answers on our ends, but it's important in a problem like this radical equation to check which of the solutions is valid. So we're going to plug in the values of x into the original equation to see which of them is consistent with the equation. Perhaps if it's not consistent, then it will be an extraneous solution. The original equation is the square root of 3x plus 4 minus the square root of x plus 2, and that's equal to the square root of x minus 3. So we're checking when x is negative 7 over 3, and when x is positive 7. Now for x being negative 7 over 3, just the left hand side we have 3 times negative 7 over 3 plus 4, and that minus the square root of negative 7 over 3 plus 2. That we said is equal to the square root of x minus 3, which is negative 7 over 3 minus 3. Now it is obvious from here that this is an extraneous solution, because everything in all the radicals, in all the square roots, we give negative values, and the square root of negative values will make the solution complex. So that simply means that here we have an extraneous solution. Then for when x is 7, the left hand side is the square root of 3 times 7 plus 4 minus the square root of 7 plus 2, and on the right hand side is the square root of 7 minus 3. Then 3 times 7 is 21 plus 4, that should be the square root of 25, minus the square root of 9, while on the right hand side that would be the square root of 4. This is 5 minus 3 on the left, on the right it is 2, and since 2 is equal to 2, the conclusion will be that x equals to 7 is the solution to the radical equation. Did you enjoy this tutorial? Please let me know in the comment section. Like and share this video. And if you're yet to subscribe to my channel, please do so right now. Click on the notification bell so that you get updates from this channel from time to time. Thank you for watching this video. Bye.